Hi, good afternoon. I'm Nils, one of the co-founders of DigiFarm. Very excited to be here, so thanks for the opportunity to speak a little bit about how we apply AI and HPC to agriculture. But I'll get started right away. So I'm an older generation farmer. I took over my family farm 10 years ago. It's just northeast of Oslo in a place called Hamar. So I have about 10 years of practical experience. And we started DigiFarm in 2019. And we started really from a core problem I saw myself, and it's agriculture's, has a lot of challenges. Digital adoption is very low. We deal with a lot of fragmentation and data silos, and I think the core thing I saw when we started is that fundamental data layer is not uniform, and it's not up to date or accurate. And when I say fundamental data layer, I mean boundaries. So boundaries is the kind of key data for in-field analytics or precision agricultural services. And today we have cadastral data as kind of the baseline of this. So I touched a little bit on this, but farmers want the car, but they get all the segments, all the pieces, and it's problematic. If you want to do variable rate seeding or fertilizing, crop protection, soil samples, yield prediction, subsidy applications, they're all in different systems, and you don't have the same underlying data layer. So actually, farmers are doing a lot of manual drawing of field boundaries. So if I can go to the next slide, I'll show. But here we go. So these are actually cadastral data. So this is called common land units. It's from the US. It's the USDA digitized these in 2008. There's 32 million of them across the US. Europe has very similar data sets called land parcel identification system in the 27 regions, and these are manually drawn into a digital map. And over time, they don't reflect really what's seeded. So when I think of boundaries, we think of really philosophically homogeneous crop zones. So one specific crop and the area that's planted and not planted. And it's a big job to do this, of course, manually. It's almost impossible to do it every year manually by hand. So over time, there's inaccuracies that grow with this. And for me as a farmer, if I needed to use this, I need to do a lot of data cleanup, like move all the vertices and the GPS points to be able to use it as input into my machinery or subsidy declaration, what it might be. So when we started, we thought, okay, well, maybe there's a way to automate this. But then we think of imagery, and we thought, you need satellite imagery data, large scale, like kind of low cost and high resolution to be able to detect it automatically. Because you need it in season to detect planted area or based on the biomass from the plants. So what you see on the left-hand side is Sentinel-2 data. It's the highest publicly freely available data from European Space Agency. It was launched in 2016. It's an amazing piece of data. The problem is it looks a little blurry, or it's a little bit low resolution. And this is problematic because 83% of all the boundaries in the world, or agricultural land, are smaller than 2 hectares. So you can't see the boundaries, so we can't detect it. And you can, of course, go to commercial-grade satellite data like Airbus or Planet and Maxar and buy this data, but it becomes very expensive very quickly. So we started building a deep neural network model about 4 years ago that does a super resolution on Sentinel-2. So input data is what you see on the left, and then we train a model to reconstruct the 12 spectral bands from Sentinel-2 from 10 meters to 1 meter per pixel. So the output is what you see on the right. So now we can see the boundaries, and then we're actually able to detect them. So what you see in the white here are the automatically detected field boundaries based on the satellite imagery data for the in-season or crop season that we're currently in when we look into this imagery. And it's significantly more representative, accurate of what the actual crop zones are in that particular farm. So if we were to buy commercial-grade satellite data, it'd be very expensive. We do it now, the ability to make commercial or publicly freely available data, commercial-grade satellite data quality equal, so to say, lowers the cost for us, of course, and then if we were to do this manually, drawing these boundaries manually every year, it'd be an expensive, big task. So, and then we get asked the question a lot: is it real, right? So it looks like magic, and to me, I'm not a technical person, so for me too, of course, there's skepticism as a farmer. But we did a project or analysis with one of our U.S. partners, and this was presented at the ARD conference in 23, where they looked at the Sentinel-2 image, which is what you see all the way on the left-hand side, and looked at AIS points or GPS points of ships in Long Beach, California, to see if they could match the length and the width and the length of the bow. And of course, in the original image, the Sentinel 2 at 10 meters, you can't really see anything else as pixels. And in the deep resolution or the super resolution Sentinel 2, which is the middle one, it's almost, it's not exact, right? Like the length and the width, but it's able to reconstruct large parts of that pixel that we can't see. And of course, we see red, blue, and green. So there's 12 spectral bands here. So it's able to reconstruct more that maybe we can't see with the plain eye. But so back to the boundaries point, we realized pretty early on that we wanted to be more training data centric than model training centric, and I think that's still key to us. It's very much in our DNA to this old saying, garbage in, garbage out, but certainly manual training data is super important. So now we have a team of 26 people for the last 4 years who've been drawing these manually, which is a resource-intensive job, but you can see all these white dots are all the training data we generated over the EU, which was our first market that we did, and today that equates to over 5 million hectares of manually drawn boundaries. And agriculture is super local, so I think that's the point. You have different agricultural practices, different crop types, phenology, climate, weather. So the ability to have local training data is incredibly important, we see, for our models to be able to do this automatic detection of boundaries in seeded acres. So the output for us is to automatically delineate approximately 700 million hectares. So of course Europe and then the US and Brazil were big markets for us, and you can see there's a whole big missing area in Africa. It's because it's super difficult, so we're still working on it, but eventually we hope we're going to be able to make some impact there too. So HPC. So we didn't have any experience with HPC when we started, and we were, I think, we read somewhere online that you could buy your own hardware. It's a lot cheaper, so you should do that. So back in 2020, we had a European Space Agency grant-funded project, and part of that, we managed to buy some RTX 3090s, 8 of them, and we put them in the office, and we thought, okay, this is going to save some cost, and it'll be great. And then we realized that they're really noisy. So we pretty early on moved them out of the office because it was too hot and everyone was complaining. And then I put them in my farm, in the basement of my farm, which was perfect because Norway's cold, basement was colder, it could heat the house up, I didn't hear it. But then you realize you got to do all this maintenance stuff with it, right? So I think that's when we realized that we need to build kind of a scalable, more reliable R&D infrastructure for this, and that was our kind of introduction to your HPC, where we managed to get some grant allocation on Lumi last year, and still today we have a very good relationship with Sigma 2, the national organization for HPC infrastructure in Norway, where we're still today the largest private consumer of the Lumi quota, and yes, I think originally we thought, okay, so hardware that would lower cost, and then we looked at do it in the cloud, and of course we ran through AWS and Google startup credits very quickly, and then realized that there's other ways to be able to offload some of this R&D, and we see a significant improvement of our model performance and output when we started using Lumi. So I think the big one is both, of course, we increase accuracy, so the output. When we measure accuracy, we do an intersection of union for segmentation, but we saw much higher accuracy that we're able to do that, but also reducing the R&D time. So training a new model and being able to see within a few days and not have to wait weeks to be able to see is it working, is it not, and then reiterate, it was a big thing for us. We're still a startup, and it's very important for us to commercialize these models. So I think that's key, and that's, yeah, it's been very, very important for us. But today we have a pretty sizable kind of data processing pipeline. So we do detection on about 600 million hectares every month of boundaries, trying to find the best models in every new region, and then kind of commercialize them, put them in their API. And we run continuously GPUs, and we certainly don't see our demand or requirements decreasing. And then we commercialize them. So once we build these models, then we're able to put them in API, and we work largely with agribusinesses and governments who use this data. So I think I have an example of some of the the governments and clients do use our data. But for example, for the field boundaries, we now work with 7 governments in Europe, which replaced the process of farmers having to manually draw boundaries to having a pre-filled geospatial data application, it's called, for subsidy declarations. So they're actually just, we detect them automatically, and then they put them in the digital map, and then they're confirming or having to reduce, maybe edit a few vertices. But it saves them a lot in kind of penalties of subsidy declarations, but also the control that you have to do as well on the subsidy. And this kind of feeds, there we go. Yeah, here are some of the clients we work with, but we work across the value chain, and this is what I was mentioning earlier, that boundaries is the first kind of touch point with digital agriculture, so it's important for all of it. When we think of machinery, C&H and Mahindra and Verge will use it for path planning, or A/B lines that you use for autonomous robotics, for example, to later down the value chain. And now we do a lot more also on kind of ESG, of course, and EUDR as well. Be able to use this because you need to geo-reference your production spots when you're declaring this into the regions. But yeah, and then we've been lucky to have some recognition in the industry, and we're totally fresh to the HPC industry, and I was really enjoying trying to learn more as well over the last few months, and certainly here, looking at all the exhibitors and people that are here, and we for us, it's very clear that the need is there, and it's certainly not going away anytime soon for us. So I still have 2 minutes, but maybe I rushed it. But yeah, I think that's really it. Thank you so much.